Hey guys, I got an email from a couple of you guys. I'm just going to go over 4 problems. We're going to be doing number 5 and number 9 from the free response. Oops, sorry, that's nice and crooked for you guys. So number 5 and number 9 from free response. And then in multiple choice, I'm going to be doing number 3 and number 9. So if you're following along, these are the problems that we're going to do. So feel free to skip around just the ones you need to see, but I hope you guys find this helpful. So let's start with number 5, which is a free response problem. If you read above, here I'll leave it down for a second. It says find the volume of the solid obtained by rotation. The region bound, find the volume of the solid obtained by rotating, the region bounded by the given curves about the specified axis. So let's look at number 5. We're going to be revolving these around the line y equals 1. So the first thing I want to do is try to draw a picture. Now, you're going to have a calculator on this test for a problem like this. So if you needed to figure out which one's on top and which one's on bottom, you could graph. You'll notice I have y cubed and y squared. If I were to sketch these real fast, I know that they both go through the origin. So a quadratic's going to go up, and I should have drawn this a little bit probably wider. But cubed is actually going to drop below, but it is going to cross, so it's going to drop a little below. Let's think about why cubed is going to be below. Well, if I cube a fraction, it's going to be closer to 0 than if I square a fraction. So if I want to label these really fast, and I know I didn't give great room for this, cubed is going to be on the bottom. And x squared is going to be on the top. And all I'm doing, okay, I'm revolving, and I'm revolving about a y equals 1. Well, y equals 1 is going to be this line. 1 cubed is 1, 1 squared is 1. So not only are they meeting, intersecting at this point, that's actually what we're going to be revolving around. So here's the thing I'm revolving. And I notice that there's a gap between what I'm revolving around and what I'm revolving. So I know I'm going to have 2 r's. So let's go through my step process, my 4-step process. I drew a picture first. Now I'm going to find my bounds. We're rotating around a horizontal, so I know this is all going to be with respect to x. I'm going to go from 0 until 1. Now I need my r's. So big R is the farther distance. So x cubed, because it's the bottom, is further from 1. So if I want to write r, it's going to be the distance from 1 till x cubed. Well, that's the difference. So it's going to be 1 minus x cubed. And then little r is going to be the distance from the dotted line that I'm rotating around to the top curve, which is x squared. So now if I'm going to write my integral, my bounds, again, are going to be from 0 to 1. I normally put my pi on the inside, but it's totally fine to move this pi to the outside. And then I'm going to have big R squared minus, squared, minus little r squared. And then there are my dx at the end. Remember, I have these brackets because I want to be clear that this pi and this dx is being distributed to everything. So now if I grab my calculator, I can go to math 9. And I'm going to go from 0 to 1. I'm going to leave my pi out for now to get an exact answer, but I'll give you an answer both ways. So I'm going to leave this pi out for right now, so I'm just going to type this. I'm going to keep parentheses as my bracket, so I need a new parenthesis for this. 1 minus x cubed squared minus 1 minus x squared squared. And there's that. I need a dx. Now remember, I did not type in the pi. So I'm going to see if I can turn this into a fraction, and I get 23 over 210. So my answer is 23 pi over 210, or I can take this and I can multiply it by pi, which is also a correct answer. Let's see if I can put it. There you go. So I have this, or I have this. Remember, we talked about in class, it's okay to do a pi with a fraction, but you can't do a pi with a decimal. So if you're going to round your answer, make sure the pi is multiplied into this. So the pi is already included in this 0.344. You can't put, like, for example, I can't put my answer as 0.110 pi. That's not okay. So I can have an exact value with the pi in it, so the pi with the fraction, or I can multiply them all together. I would take both of those answers. Okay, so that's number 5. Let's skip to number 10. Or sorry, that was number 5. Let's skip to number 9. on the free response. Okay, it says let the base of a first quadrant region enclosed by y equals x squared and y equals 3. If all the cross sections perpendicular to the x-axis are semicircles, so the first thing I notice is it's x-axis, so it's with respect to x, and I also notice that it's semicircles. We have a formula for the area for semicircle, is it's 1/8 pi side squared, not radius, a side squared. Remember the side's going to be that distance, and we'll worry about that in a minute. Find the volume of the solid. So, step one, remember, is always to draw a picture. Notice it says the first quadrant region, so if I didn't say that, this would be a different area, but it's going to be x squared and y equals 3. Again, if it wasn't first quadrant, I'd also have the piece over here. Okay, the cross sections are perpendicular to the x-axis. We know that this is y equals 3. What squared gives you 3? Well, root 3 squared gives you 3, so it's going to be root 3. Okay, so let's go through. So that's step 1, draw a picture. Step 2 is to find my bounds. Well, my bounds are going to be from x equals 0 to x equals root 3, because remember, we're moving along the x-axis. Okay, well, because I'm doing cross sections, we're going to integrate the area of a cross section. Well, my formula for area, we already said, is 1/8 squared. Well, I need to know what a side is, and remember, a side is the distance from the top to the bottom of my area. Well, this top thing is y equals 3. This function is y equals x squared. Well, if I want the distance between the two, I take a difference. So it's going to be 3 minus x squared. So now if I'm going to set up my integral, my bounds are from 0 to root 3. Remember, my area for a semicircle is 1/8 pi of something squared. Well, my something is 3 minus x squared dx. Okay, well, now I can type that into my calculator. I'm just going to type it with pi in the answer this time. So I'm going to stick my pi out the front so I don't have to worry about it. Okay, math 9. I'm going from 0 to root 3 of 1/8. Got to make sure you're careful with this, that 1/8. So you're multiplying that by everything. My pi is already at the front. And then I have the quantity 3 minus x squared. Squared. 1/8, I've got that. My pi's at the front. It's good to double check sometimes just to make sure you typed in the way you intended to. So remember, on the AP exam, we round to the thousands place. So if I rounded, that'd be 3.265. But technically, you can also truncate as well. So I would also accept 3.264. Please don't box both of those answers on the actual test. Pick one or the other, but both would be accepted. Okay. So those are the 2 free response I was asked about. Let's skip and do the 2 multiple choice. So let's start with number 3. It says the area of the region enclosed by the curve this, the x-axis, and the lines x equals 3 and x equals 4. Remember, bounds can be, we can get them from intersection points, or we can get them from vertical lines. So in this case, it looks like vertical lines. If it's been a while since you've seen this graph, one of the things you can do, since you'll have a calculator, is just to type it in and see what it looks like. So I'm going to do my alpha y equals to get that fraction. And then that's going to be x minus 1. I'm going to make sure I have a standard zoom. Okay, so there's what my graph, I only want from 3 to 4, so I'm only going to do something kind of happening in this region. So if I were to just sketch a picture real fast, I notice that it's kind of doing one of these things. Okay, so we're going to make this 3. And here's 4. So I just want what this area is. So I already have my bounds. It's going to be from 3 to x equals 4. And I'm just doing area, so it's just going to be the integral of top minus bottom. So I'm going to do the integral from 3 to 4. The top is 1 over x minus 1 minus the bottom. Well, the bottom's just the x-axis. That's y equals 0. So I don't need to show subtracting 0, but you can if you want. Dx. We're going to plug that in. So I'm going to have math 9 going from 3 to 4 over, if you don't do a fraction, or if you don't turn it, like use the alpha y equals to get into nice fraction form, make sure when you're doing a denominator, You're using parentheses because I want to be clear that the x minus 1 is all underneath that 1. The whole thing's the denominator. I need a dx. And that gave me 0.405. Okay, well, here's the thing about this. Even if that's my answer, none of these look like that. So the first thing I might try to do is just do a math frac and see if that gives me any of my answers. And it doesn't look like it did. So if I'm stuck in a position like this, the easiest thing to do is just test all of my answers and see which one is. So let's see if I can get my everything to show. Okay, let's type in 5 over 36. We already know that that shouldn't be it because the math frac didn't work. Let's try ln of 2/3. Oopsies. That was negative, so that doesn't look quite right. Let's try this one. Nope. Let's try this one. Positive. Okay, so this actually would have been a decent one to look at because this one was negative and they're flipped, and logs and exponents are related, but let's not worry about that right now. But if you test them in and you check them with this, you'll notice that this matches this answer, so the correct answer is D. So a thing to remember whenever you have a multiple choice question or a test, if you can get the setup right, sometimes you can also plug in and see what happens. So just a reminder that when you have multiple choice answers, you're already down to a set number of answers, and sometimes you can guess and check a little bit. In this case, we still had to get the answer first, and then we checked them against them, but just a good skill to have. Okay, we've got one more to do together real fast, and that's number 9 on the back. This was the multiple choice on cross sections. Hopefully I can squeeze this picture in. It says the base of a solid is a circular region bounded by the graph of x squared plus y squared equals 25. Well, we've done a lot of these now, and I hope you're remembering that this is the equation of a circle, specifically with a radius of 5, because that is the square root of 25, because the equation is x squared plus y squared equals r squared. So the radius squared is 25, the radius is 5. Find the volume of the solid if every cross-section perpendicular to the x-axis. Okay, so we haven't done any y's in this video, but that's okay. So perpendicular to the x-axis is an equilateral triangle. Okay, so let's think about this real fast. We have a formula for this. It's the root 3 over 4 sides squared with one side, the bottom side, on the base. Okay, well, now that we've gotten this all set up, it's really not that bad. My bounds are going to be from -5 to 5. They're x values. Okay, my area, we already said, is root 3 over 4. That's a 3. So I'll try to make that a little clearer. So root 3 over 4 side squared. Well, now I have to think about side. That's actually kind of the tricky part here. Remember, a side is going to be where this cross section is. This currently isn't written as y equals. Because I'm doing things with respect to x, the x's should be, I should have y equals and then stuff with x's. So I need to solve this for y. So I'm going to do this up here real fast. So if I solve for y, I'm going to subtract the x squared on both sides. I'm going to take the square root, and when I do that, I get plus or minus 25, the square root of 25 minus x squared. So this here is the square root of 25 minus x squared. This here is a negative root 25 minus x squared. So if I want this full distance, top minus bottom, I need to do this minus this. Well, if I do this minus this, I'm going to do this minus a negative this, so it's the same as adding them together. Since these are the same, it's the same as having 2 of them. So I'll try to write this out real fast, but I know space is a little tight. We're doing the top curve minus the bottom curve. Okay, so my s is just 2 of this. So for space, I'm gonna write this out now. My bounds are from -5 to 5. My formula is root 3 over 4 side squared dx. Well, what is my side length? It's this, and we said since we're subtracting a negative, it's the same as adding them. So I have 2 square root of 25 minus x squared. So let's see if we can type that in now. I have math 9. I'm going from -5 until 5 of root 3 over 4 2 root 25 minus x squared. Quantity, all of this needs to be squared. Make sure my parentheses are good. dx. Okay, let's see if that's one of my answers. Ah, there it is. So there's my answer to number 9. So don't forget, there's a key up for this on Blackboard. I hope you guys find this helpful. The test is going to take the whole class on Monday, so come in ready to go, and make sure you bring a calculator with you. See you guys then.